Okay, today we are going to start Unit 1, which is Introduction to Functions, and there are 5 learning targets for this unit. We are going to kind of go through them out of order. So you'll see the first one is represent relations as graph tables, ordered pairs, and or mappings. Second, we are going to determine if a relation is a function, and those two kind of go hand in hand, so we're going to do them today. Then we're going to skip ahead to 1.5 and identify domain and range for relations that are represented in different ways. And then we're going to do 1.3 and 1.4, which is understand features of function notation and identify input and output and using function notation to evaluate. So we're going to start with day 1, 1.1 and 1.2, relations and functions. So in your packet, it refers to pages 2 through 5. This packet will give you almost everything that you need for the whole unit. So we're going to go ahead and turn to page 2. Okay, so here we are on page 2. We are going to look at different representations and also determine if a relation is a function or not. So the two most common representations of relations and functions that you are used to seeing are shown here in 2 and 3. So we have a graph here and a table there, and you have used those quite often so far in algebra or pre-algebra. The one that you're not used to seeing is this first one, which is actually called a mapping diagram. And what this does is it actually pairs up ordered pairs. So this is telling you your x's and your y's, or your domain and your range, which we'll talk about later on. This is telling you that you have a point at 1, negative 2, and you have a point at 2, negative 2, and a point at 3, negative 2, and a point at 4, negative 2. Very similar to a table. It's telling you have a point at negative 1, 4, negative 2, 5, negative 3, 6, negative 4, 7. A lot of you are also used to seeing tables this way. It does not matter which way you write them, so it would still show us the same thing. Okay, let's look at some other representations here. Number 4 representations you've also seen. Those are just ordered pairs. Okay, again, 5 is that new one, which is a mapping diagram. And 6 again is a graph. Okay, I apologize, my handwriting's sloppy tonight. And then you'll notice here it's asking one really important question on all of these, and that's, is the relation a function? Okay, and there are 2 ways to tell. The first way to tell is by looking at your ordered pairs that you have. So that would be the mapping diagram, the table, or the ordered pairs, and deciding if each x only has one y that's paired up with it. Okay, so notice that 1 only goes to one number, 2 goes to one number, 3 goes to one number, 4 goes to one number. So essentially in a mapping diagram, if there's only one arrow from each of your x's, you're good. So what we say is, yes, this is a function, because each input has exactly one output. Okay, so let's look at the table. Notice in this table that negative 1 only shows up here once. Okay, so that's kind of like saying there's only one arrow there, or I could make this a mapping diagram if I wanted to. And if each x value only shows up once in your table, that means it is also a function. Some students actually like to change this to a mapping diagram. So if we have our x's and our y's in our mapping diagram and you draw your arrows in, you'll notice that each x value only has one arrow. So again, yes, this is a function because each input has exactly one output. Okay, for your ordered pairs, we're going to do the same thing. We are going to, you could actually make a mapping diagram again. Notice that all of these have 5s for our x's. So if we made a mapping diagram out of this, we just have a 5 there. We have 9, 2, 0, negative 5, negative 10. and then we would draw arrows. Okay, so is this relation a function? This one's not, because 5 in the input has more than one output. Okay, so we're going to look one more time at a mapping diagram here. Notice when we look at our x values in the mapping diagram that 15 has 2 arrows coming from that. So again, that means it's not a function, because 15 in your input has more than one output. Okay, so that's really what you're doing with any type of representation besides a graph. You're going to look to see if your x value shows up more than once, or if there's more than one arrow coming from an x value. And it helps sometimes to make a diagram just to be able to tell, because then you can look for those arrows. For the graphs, we're going to do something called the vertical line test. And what that entails is taking a vertical line. So I'm going to go ahead and draw a red vertical line here. Maybe not quite that big, so let's fix that. Okay, and if you have a graph, you can take a vertical line and drag it across the graph. So I'm going to do that slowly. I'm just going to move this straight across my graph. And if your line ever touches your actual graph at more than one point at a time, so like right here, it touches the graph, and right there it touches the graph, if it ever hits at more than one point at a time, that means it's not a function. And what we say for a reason there is that it fails the vertical line test. Okay, so let's look at this graph down here. And if I drag this across, notice that it only ever touches the graph at one point at a time. It never crosses at more than one point at a time. So this one would be yes, because it passes the vertical line test. Okay, so our takeaways here. A relationship between two sets of information, two numbers, is called a relation. Okay, when relation pairs each input value with exactly one output value, it's called a function. Okay, so we always have relations. Sometimes they're functions. So input is your x value, domain or independent. Output is your y value. And I'll let you do those last two just to start thinking a little bit about this more.